Today, we're super duper lucky to have Dan Fu. Welcome to the podcast.
Hi, super happy to be here. Thanks so much for having me.
Of course. So Dan, you've done a lot of really amazing stuff. And I know that you're now essentially an assistant professor at UCSD, which is super duper exciting.
Mhm.
Before that, you were getting your PhD at Stanford, and before that, you spent some time in undergrad. Walk us through a little bit about like how you sort of got interested in ML systems.
Yeah, it starts in undergrad really. When I was in undergrad, I was very interested in systems in general. I had some really great professors who kind of got me down that path with kind of intro systems programming, operating systems, kind of that sort of thing. And I really like that way of thinking. Back then, machine learning, deep learning was kind of just starting to kick off. There were some demos from Google that you could detect cat videos. There were some, uh, ImageNet was around. There were some architectures. People were very interested in ResNets and things like that. There were some inklings that maybe we might get self-driving capabilities in the next 5, 10 years. So this is like a 2014 era. People were starting to talk about self-driving. This was before ChatGPT, before the GPT models. OpenAI was still doing like DOTA research, so they were doing reinforcement learning, playing video games, and things like that. And it was kind of a for me it was machine learning AI was really interesting, um, but I kind of wanted to have my own angle to attack it, and I had this other great interest in systems. So when I started my PhD, I really knew I wanted to kind of combine them in some way and do machine learning systems research, and that's kind of how it all started.
hmm Awesome. So walk us through like a few of your experiences during undergrad. Like, were you doing research? I assume you were, and before getting to your PhD at Stanford, like, I guess what
Mhm.
sort of motivated you to pick the specific lab that you ended up doing at Stanford?
Yeah, in undergrad, I kind of hopped around, did a few different research projects. I think my first, I'll call out a few experiences that were really, transformational for me, or maybe not transformational, but really helped set somebody down that path.
hmm
So one I have to call out Mario Seltzer. She was a professor at Harvard at the time. Now she's at UBC. And she was just known for being a really great mentor. And she was a great mentor to me. I think I'm lucky to count myself among her students. The first time that I really kind of touched research in undergrad was I was doing this internship after my freshman year at a startup called Tamer. It was a Mike Stonebreaker startup from out of MIT, and it was one of the first places where people were kind of combining machine learning and systems. So their whole thing is you have these production databases. You probably have a bunch of duplicated schemas, duplicated tables across things, and they had some for what would now be considered some pretty simple machine learning, like some machine learning heuristics and algorithms that you could actually implement literally in SQL. That's not like the transformers deep learning that we're talking
hmm
about today. Um, but that was the first instance I saw of this was a set of research projects out of MIT that kind of grew into a startup, and that was the first time that I really kind of got any inkling of what research was. I kind of didn't really know what it was before that, right? You kind of
hmm
hear this term, you think of scientists in a lab, in a wet lab somewhere. I'm like,
hmm
I've never seen a computer science person in a wet lab, so I didn't really know what computer science research was. Um, After that, I took a couple courses, a system security class with James Mickens, where there was this final project with a research component. A friend and I, we did a somewhat interesting project for that. I was like, oh, I kind of like this. I kind of like this self-directed thing. Um, After that, I took a few more classes with research components, kind of jumped around. There was this one paper I wrote in undergrad about bird flocking
hmm
using Boyd's algorithm. If you know that, it's some old graphics algorithm that they used to simulate flocks of birds from that they used, I think, in Batman Begins. So
Mm-hmm.
very little correlation with anything
Yeah.
real, and I think no application whatsoever. But I found that project really fun, and just digging deep into something, exploring everything deeply, and kind of around my probably sophomore junior year, that's when I kind of knew, hey, I like this research thing.
Mm-hmm.
I want to get more involved, and that's when I started thinking about doing a PhD.
Mm-hmm. Awesome. Yeah, and I know like you spent a little bit of time during, some of your internships. I think you spent some time at Google, doing SWE stuff, and then you were also doing some research at Argo AI. Like you talked about, a
Mm-hmm.
little bit of field engineering stuff at Tammer. So I think like one thing a lot of students wonder, and I guess like a lot of the people in the audience are probably honestly grad students or people in industry or maybe even some undergrads, is like sort of how to get relevant domain experience while they're still in school, or like what types of things they should, try out. What would you say is like some of your advice or like some of the experiences you might want to highlight that helped influence you to get to where you are right now?
Yeah, that's a great question. I think if you look at those experiences I had, so what you're referring to, so I had this field engineering internship at Tamer.
Yeah.
I did some a couple SWE internships at Google during my undergrad. The Argo stuff came later. But really, what I was doing in those was kind of feeling out what it would feel like to work in industry versus what it would feel like to do research.
Mm-hmm.
So honestly, if you're someone who you've done a lot of research, so actually, so what I tell undergrad students now is, if you think you want to do a PhD, then the best thing to do is just to get research experience.
Mm-hmm.
Not only and primarily the reason is that you want to make sure that you enjoy doing research before you commit to doing this PhD for 5 6 years. Because really it's a, it's paid, so you have a stipend, but really it's a very, the way to think about it is a PhD is a very expensive endeavor
Mm-hmm.
in terms of the opportunity cost. So if you think about it, a SWE coming out of a top school and a top CS school in undergrad, you can probably be making six figures right out of the bat, times 5 to 6 years, a
Mm-hmm.
promotion or two, and you're
Mm-hmm.
really talking about 600, $700,000 of income.
Mm-hmm.
Whereas in a PhD, it's going to be what, like 40,000 a year for 5 6 years. So you're
Mm-hmm.
really talking about something like $500,000 of lost income. Not to mention stocks, appreciation, like all those things. So it's really something that you want to go into clear-eyed and realize and know why you're doing what you're doing. And for me, those internships in undergrad were really trying to feel out what does a industry experience feel like? Would I want to work at a company or a big company?
Mm-hmm.
And really, being confident that the PhD was what I wanted to do.
Mm-hmm. Awesome. Yeah. I know. So your undergrad thesis, I know this is something a lot of Harvard students spend a lot of time on in their last semester, last time. You think we talked briefly about flocking, but I guess your thesis title was Design of Influencing Agents for Flocking in Low Density Settings. I guess anything about the thesis experience that you might want to share, because I know it can be kind of formative, maybe like for a lot of students, their first time like really writing a very long, thingy, like a very long document.
Mm.
How did that sort of influence you? Anything you might have learned from that experience?
Great question. I'll be perfectly frank. The main
Yeah.
thing I took away from that is that I don't want to work on problems with zero application.
Okay. Okay. That makes
So
sense.
I'll just set it up.
Yeah.
I think the this influencing agents and bird flocking thing, it's a fun little problem to kind of tickle your brain.
Yeah.
The applications are really extremely made up. So
Yeah.
the idea is you have these flocking algorithms that describe. So a flocking algorithm is basically if you have a bunch of independent agents, like in this case, simulating birds,
Right.
and the way that you kind of mimic the starling type of flocking or like bat flocking in Batman Begins is you say that each bird kind of knows where it wants to go, but really it's going to follow all the other birds near it.
Mm-hmm.
And then if you do this and you simulate it, you get some somewhat nice, some pretty simulations.
Right.
The influencing agent bit is just let's say you wanted to turn that flock, and
Mm-hmm.
for some reason you had control over one of the
Mm-hmm.
one of the birds. How would you do that? And
Mm-hmm.
the insight, it's not super difficult. If you have control of one of these things and you want
Mm-hmm.
it to go left and all the birds are going right, if
Mm-hmm.
you just send the your agent through going left, it's
Mm-hmm.
just going to fly through and not have
Yeah.
any effect. What you have to do is you have to direct your agent to kind of follow the flock first and then slowly
Yeah.
turn it over time, um, which is pretty obvious if you sit
Yeah.
down and think about it. And the
Still
applications
cool.
are really like, I think we wrote, hey, or one of the papers that we said was like, hey, remember that Sully Sullenberger over the Hudson thing where those bird flocks ran into that plane? What if you could redirect the bird flocks? Um, which is a really silly thing to do, right? Like
Mm-hmm.
just put up a scarecrow or something.
Yeah. Yeah.
There's really not much application. So what I found in that was I found it interesting. I found it fun to kind of optimize this and think about the various ways to do
Yeah.
it, the various algorithms that we tried.
Yeah.
But at the end of it, I was like, what was the point? So
Right.
really going into my PhD, I was like, I want to work on problems that
Mm-hmm.
are both interesting, but also have some concrete application.
Right, totally makes sense. And I guess like fast forward to today, I guess your two main interests are hardware-aware algorithms for ML and efficient ML architectures. And you've worked on a lot of really
Mm.
exciting papers in the past few years. So walk us through how you got from this bird flocking thing to all these really exciting papers that are now making a huge impact. Like, I assume that wasn't a trivial thing to do. Definitely took some time and effort and support from your advisors. Any like key moments along that journey that you might want to highlight?
Yeah, so I can just kind of walk through my overall PhD journey.
Sure.
I would describe it, more as a wandering path
Mm-hmm.
than any sort of real, targeted thing. Like
Yeah.
there's some people who do PhDs and kind of see from paper one to paper end, they have a
Right.
very
Right.
clear idea.
Right.
I was definitely not like this at all. So my first research projects were so I'm to give some context. I was
Yeah.
co-advised by two really great Stanford professors,
Mm-hmm.
Chris Ray and Kayvon Fetahalian.
Mm-hmm.
My first project was so Kayvon had gotten his hands on something like 10 years of cable TV news
Mm-hmm.
through the Internet Archive,
Mm-hmm.
and we just wanted to be able to ask basic questions about it, like basic sociological questions like
Yeah.
what's the screen time of men versus women,
Mm-hmm.
or what topics do they talk about.
Mm-hmm.
But this was so 2018. You had some very basic ResNet models, nothing like what we had today.
Right.
And it was really, really hard to try to analyze 10 years of cable TV news footage.
Mm-hmm.
So the very first project I worked on was this video analysis thing called Recall,
Mm-hmm.
named after the Total Recall thing in the movies.
Mm-hmm.
So spelled with a K as well.
Right.
And that was really about more or less if we can use these pre-trained, we called them pre-trained neural networks at the time. So like
Mm-hmm.
a pre-trained ResNet, pre-trained over ImageNet,
Mm-hmm.
how can we leverage all of those things, or like an object detection model, how can we leverage those things to start to query and ask questions of this database? So it was really building a SQL-esque language to try to query these these collections of videos, and try to understand what was going on.
Mm-hmm.
It kind of, it was interesting to work on. I still have a soft spot for video today. I think it was a little bit early for the research I did. To give you some context on the type of reviews we got, this was 2018, so
Mm-hmm.
pre-clip, pre-dolly, pre anything.
Right.
We sent it to the databases community. They said, oh, what if you could use natural language to query these videos? And today that is something
Yeah.
you do. You just
Yeah.
like put all the frames into Gemini and ask it something. But
Right.
this was 2018 before we had any models that could do it.
Right.
From there, so this type of querying looked a lot like a set of projects that Chris was working on called Weak Supervision that eventually turned into this company Snorkel that's now very successful,
Mm-hmm.
where you write these programmatic functions to try to, again, label data,
Mm-hmm.
noisily label data. So, these queries we were writing could kind of interpret them as these programmatic labeling functions.
Mm-hmm.
And so I did a series of projects on trying to do weak supervision for video and long modalities and kind of expensive things.
Mm-hmm.
And I did that for maybe a year.
Mm-hmm.
At that point, it was becoming clearer and clearer to us. Like GPT-3 had happened, that these big pre-trained, we didn't call them foundation models yet, but today we
Mm-hmm.
call them foundation models. It's kind of becoming more clear that these things were going to have some huge impact in the future.
Mm-hmm.
And we were trying to figure out how to use them.
Mm-hmm.
So we're trying to figure out how to study them.
Mm-hmm.
And so kind of tying in with the video background, I had this whole series of papers looking at contrastive learning,
Right.
which is how you trained a series of models called SimClear or Clip back then.
Mm-hmm.
Kind of fell off. Today it's all diffusion models and things.
Mm-hmm.
That was a much more theory focused set of work,
Mm-hmm.
which was, interesting to think about. I think if people are studying embeddings today, there's maybe something to learn from that.
Mm-hmm.
But I think my experience this brings me up to like year 3 or 4 of my
Mm-hmm.
PhD.
Mm-hmm.
My experience through all of those was I could kind of dig my teeth into something, but nothing was really clicking in
Mm-hmm.
kind of the right way. And I kind of really hadn't found my niche yet.
Mm-hmm.
So after the contrastive learning, I was kind of looking around, trying to look for new things.
Mm-hmm.
And then at that point, I kind of decided, hey, maybe I'll go back to my roots. So all that system stuff I was doing in undergrad,
Right.
and understanding hardware, understanding low-level systems programming, all those things. Maybe there's something to do there.
Mm-hmm.
And that's when I started working on Flash Attention.
Mm-hmm.
And that was really the first project I was like, from the get-go, I was like, oh, this kind of feels right.
Right.
Like the grunt work of it, like writing code, that's kind of seems fun. I can see the application. It seemed really obvious to me. It was unclear to me why somebody else hadn't done before.
Right.
And that was a feeling that I was like, oh, okay, this is kind of what it feels like to work on something that I know is important, that I know I have the skill set to do, and that I really want to kind of like, you know, you wake up in the morning, you feel excited about it.
Right.
From there, we did more hardware-aware stuff around convolution, state-space models,
Right.
and various things. And that through line has kind of been the through line of the work that I've been doing since then.
Mm-hmm.
But if you look at my PhD, it really took me years to get to that point, and a lot of trial and error, a lot of exploration.
Right.
Yeah, which is so. If you're in that stage in your PhD, if you're in year 3 or 4 and you're feeling kind of lost, I guess my advice would be that's totally normal. It happens to everyone.
Yeah.
When you find the thing, then you kind of get running. But you have to try a lot of things before you figure out what that is.
For sure. It totally makes sense. And yeah, definitely appreciate the honesty with this. PhDs are never trivial for anyone, I don't think. Even if they have a preset path, it's definitely, especially nowadays with open review, definitely kind of non-trivial. The review process is also a bit interesting. Okay, cool. So 2 things I think are also really interesting that you've done a great job of. Okay, maybe 3 things. One is your open source contributions. You've had a lot of different open source artifacts that you've worked on. Flash Attention's one. I guess like you had Red Pajama 1 trillion, which I thought was also pretty cool. Yeah, like the Safari convolutions for sequence modeling, Flash FFT conv. So maybe you want to learn a little bit more about your open source artifacts. So let's go ahead and start with that. You want to like walk us through a little bit of like kind of what motivated you to open source this? What was it like interacting with the open source community?
Yeah, great question. I think the DNA of machine learning is open source.
Yeah.
So, and that's because, and it's a really great thing. I think there's of course companies now that are trying to change that a little bit for competitive advantages or whatnot. But it's really a huge reason why we were able to move so fast and have so much impact in relatively few years. From 2019, 2020 to now, like the world has changed, largely, due to AI and foundation models and things. And that's because people release products, they open source things, they open source models, they open source software libraries, and that's really great. So I think it's just kind of part of the community. If you
Right.
claim that you have something and then you don't open source it, you don't let
Yeah.
people use it, um, uh, a great part of the community is that people are still skeptical. So
Right.
there's a strong incentive for people to still continue to open source things today.
Hmm.
And going up through my PhD,
Yeah.
it was just necessary. Part of the
Yeah.
um, kind of table stakes of if you have some work that you're proud of,
Yeah.
you have to release it. You have to
Hmm.
open source it, give people a way to use it in order for people to really take it seriously. So
Hmm.
that's a huge motivation. But also from the pure research side,
Hmm.
when you open source things and you get feedback, that feedback is extremely valuable. So when you hear, we release Red Pajama and people are like, oh, this is a really great attempt to recreate Llama, but there's more you can do on the data mixing side. So actually
Right.
selecting what proportion of these different sizes of data to use,
Right.
that turned into a whole line of work.
Right.
You release flash attention and people are like, oh, this is great. I can fit a lot longer sequences in memory now and has a ton of usage. But when I go to super long sequence, the computation is still really expensive. Okay,
Yeah.
that informed we should go look at these subquadratic models, these new
Yeah.
architectures.
Yep.
You release a new architecture and people are like, oh, it doesn't run as fast as it should because of the big O. And you're like, okay, this is really great feedback. We need to
Hmm.
go look closely at the systems thing. So that informs Flash FFT
Yeah.
and all those things.
Yeah.
So if you do it right, open sourcing kind of creates this flywheel where you can work closely with the community to figure out what is interesting to people,
Hmm.
what are the kind of the right next steps to take,
Right.
what would be really impactful and
Right. Totally
um,
makes sense.
for people.
Yeah, so I think we're getting kind of close to time, so we'll end with two questions. One is about your time at Argo AI and Together AI, which you've now been at. As a research scientist at Together AI, as a research intern at Argo AI, definitely a little bit different than SWE at Google or field engineering at Tamer, I would assume. So maybe walk through, a little bit of how that experience has been, and maybe if you want to share a little bit about Together AI to the extent you're able to. And then the second, just about like what you're excited by now, like what trends you're seeing that you want to work on, what topics you're on. I know you might still be recruiting students and probably will be in perpetuity for the next few years. So like what would your message be to, maybe potential students that are watching the podcast?
Right, right. Yeah, I'll talk briefly about Together. So now I have the great fortune to be leading the kernels team at Together AI.
Hmm.
So kernels like Flash Attention, Flash FFT, Thunderkins kernels, Thunder GQA. Um, we're writing production versions of those, figuring out how to really push the frontier of fast inference at Together using kernels. So being
Hmm.
very creative with how we write kernels,
Hmm.
and how we can be more productive and really squeeze the most out of GPUs and other hardware.
Hmm.
So that's been really fun at Together. It's it's pretty industry is pretty different from research.
Right.
Leading a large team of folks, setting long-term agendas, but also hitting, demonstrating clear impact, and aligning your work with business incentives, business interests, all that. It's really fun, really engaging, um, really challenging,
Mm.
but it's really fun to do. So I've been having a lot of fun doing that at Together. Um, in terms of uh, what I'm excited about going forward and with students. So there's a lot more to squeeze on modern GPUs with creative kernels, with new approaches, things like mega kernels and
Mm.
things like that. Um, there's just a lot more to do. We haven't even scratched the surface of how far we can push, for example, inference efficiency on even NVIDIA GPU. So even the
Yeah.
some of the most important workloads on the most popular hardware, there's still so much to do.
Mm.
So there's a lot of really interesting uh, research questions to ask,
Mm.
and really interesting things to look at there. Um, I'm also interested in diffusion models,
Mm,
video diffusion models. I find video diffusion really compelling, but extremely
mm,
expensive.
right.
So pushing the boundaries there, pushing the frontiers there, and figuring out how to make things more efficient, make things run faster is really engaging, really exciting.
Mm,
Um, yeah, so that's kind of a loose sampling of things that I'm interested in.
mm,
I want to get back more into numerical algorithms like FFT,
mm,
FFT family. That's something that you can really only do in academia because it's not extremely financially valuable right now
right.
for the frontier models, but I think could be quite. First of all, it's just really interesting,
Mm,
but also I think there's so many applications of these numerical algorithms that there's a lot more to do.
mm.
Yeah, so if you're interested in any of those things, I'm always looking for really talented, really hardworking students.
Awesome. Yeah, and I guess like Dan's been very humble throughout this, but on top of all this stuff that we've talked about, he also TA'd a bunch of classes at Harvard, and then also was I think you taught 528, which is like the MLSys seminar at Stanford.
Mhm.
And he's also the founder of the very very popular Stanford MLSys seminar. So definitely has done a lot of really amazing stuff across a lot of different spheres, and that's not an opinion, that's just a fact. So definitely, I think it would be great to work with Dan. So if you're interested in ML systems, you should definitely reach out, and we'll have his email down in the description for the video. All right. Well, thanks for your time, Dan. Really appreciate it.
Yeah, thanks so much. Thanks so much for having me. It was great chatting with you.